At 9:58 AM, a Marine Corps AH-1Z Viper attack helicopter was thundering southward across the Caribbean at 150 knots, zeroing in on a cartel vessel whose crew had absolutely no clue they were about to become part of the ocean floor. This flying weapons platform, essentially an airborne armory with serious attitude problems, had lifted off from the USS Iwo Jima a quarter of an hour prior. In precisely 12 minutes, this high-speed boat would learn why taking on the US military is like trying to outswim a shark while covered in fish blood. The aviator's gaze was fixed on the targeting information flooding his helmet-mounted display. Distance, 18 nautical miles. Combined approach speed, 195 knots. Countdown to weapon deployment, 7 minutes. The vessel racing below remained blissfully unaware that freedom was inbound from the north at 150 knots, satellite guided, aircraft tracked, and about to be personally delivered by a Marine who hadn't missed since training. The FLIR screen revealed the boat's engine heat signature, 2 blazing white spots against the Caribbean's cooler blue backdrop, speeding northward like they actually stood a fighting chance. AP-8 Poseidon maritime surveillance aircraft circling at 20,000 feet was maintaining target lock. The P-8 represents what happens when Boeing takes a commercial 737 and, instead of cramming in more passenger seats, loads it with $400 million worth of detection equipment. Its ANAP Y-10 radar system had identified the telltale smuggler profile. Twin engines, 45 knots, northbound from Venezuela along what traffickers call the Caribbean Highway, basically Interstate 95 for criminals. The P-8 had even deployed acoustic sensors to monitor engine sounds. 2 Mercury 300 horsepower outboards running slightly off rhythm, suggesting the cartel had skipped maintenance this fiscal quarter. Within the Viper's cockpit, the pilot was inputting target data into the TSS integrated with his helmet display system. The TSS, Target Sight System, is essentially Iron Man's helmet designed for rotorcraft. This $200,000 piece of technology weighs 4.6 pounds and projects targeting information directly onto the pilot's visor, enabling him to designate targets for elimination simply by head movement. The slaved FLIR pod meant the infrared camera tracked wherever the pilot looked, with resolution sharp enough to detect a candle flame from 5 kilometers distance. The Viper came loaded for maximum impact. 8 AGM-114R Hellfire missiles were mounted on the stub wings, 4 per side. The Romeo variant was specifically chosen for this operation due to its multi-purpose warhead design. It doesn't require target identification, it simply needs to eliminate whatever it hits. Each missile weighs 108 pounds, stretches 64 inches long, and costs $150,000. That's essentially a college education being delivered at Mark 1.3 to someone who definitely didn't enroll. The pilot had configured the laser PRF code to 1113, pulse repetition frequency, essentially a unique signature for the laser beam so the missile follows only this specific guidance, ignoring solar interference, other laser sources, or any hypothetical disco equipment that might somehow end up in the Caribbean. The military learned about target confusion through painful experience, which is why every laser now gets its own distinctive identifier, like a lethal phone number only one missile recognizes. The helicopter's arsenal wasn't limited to Hellfires. The nose-mounted turret housed an M1973 barrel 20mm Gatling gun with 650 rounds, capable of rotating 120 degrees in either direction. It could perforate a vessel from 2 kilometers away. But why use ammunition when you have a missile that calculates its own trajectory? Via Link 16 datalink, the military's equivalent of group messaging, except instead of sharing memes, it transmits targeting intelligence, the P-8 was providing real-time updates. Vessel speed, 45 knots, bearing 350 degrees. Time to Venezuelan territorial waters, 15 minutes. Time to Hellfire impact, 12 minutes. The mathematics were working out about as favorably for the smugglers as a screen door on a submarine. At 10:06 hours, the Viper had reached engagement range, and the pilot activated the laser designator integrated into the TSS. Suddenly, a boat that believed it was operating covertly was being illuminated by 20 milliwatts of light at 1.064 microns wavelength. While invisible to human vision, to the Hellfire's seeker-head, this laser appeared like a massive Las Vegas sign advertising an all-you-can-eat buffet. The vessel had begun evasive maneuvers. 45-degree course changes every 30 seconds. The TSS auto-tracking mode maintained laser focus on the target using predictive algorithms that could anticipate the boat's next move better than the boat's own crew. The laser energy reflecting off the fiberglass hull created a sparkle pattern approximately 2 meters wide. The boat was essentially performing as a disco ball for incoming ordnance. The helmet system was making micro adjustments through sophisticated technology. When the pilot shifts his head even fractionally, electromagnetic coils detect changes in field strength and orientation. This data feeds the turret control computer at 60 updates per second. The system precision can detect movements as minute as 0.1 degrees. When the pilot focuses on something, the nose-mounted FLIR turret aligns with his view in under 200 milliseconds. It operates on the same principle as Hollywood motion capture suits, except instead of animating CGI characters, it's directing weapon systems. The pilot can literally look at a target, lock it with a button press, then shift to the next target while maintaining the first designation. The computer compensates for aircraft movement, vibration, even the pilot's respiratory patterns to maintain steady lock. Configuration time arrived. The pilot selected LOBL, lock on before launch. There's also LOAL, lock on after launch, where the missile fires blind then acquires the laser, but that's for when you're feeling adventurous. For a vessel performing evasive maneuvers on open water, LOBL was the logical choice. Attack profile selection came next. Top attack mode makes the missile climb, then dive vertically. Perfect for armored vehicles with vulnerable roof sections. Direct attack sends it straight at the target. For a fiberglass boat with the structural integrity of a pool toy, direct attack was the clear winner. The pilot wanted waterline impact for maximum flooding and minimum floating capability. The fuse setting was instantaneous contact. The Romeo variant offers delay options for hardened bunkers requiring penetration before detonation. But fiberglass vessels provide about as much protection as swimwear in a paintball tournament. Instantaneous contact would ensure the 20-pound warhead made proper introductions the moment they met. Inside the selected Hellfire, sophisticated systems were activating. The missile's seeker head was cooling to minus 200 degrees Celsius using compressed argon gas. This supercooling reduces thermal noise in the detector, enabling detection of the faintest laser reflections through its germanium lens window. The seeker was already tracking that 1113 PRF pattern, filtering out sun glint, wave reflections, and everything else. It could see the laser sparkle through its 30-degree field of view, waiting for release like an extremely expensive, extremely angry delivery service that's never late. The missile's internal systems ran pre-launch diagnostics. The ring laser gyroscope spun up to 40,000 RPM, ready to track every movement during flight. The missile's computer initialized, loading flight control algorithms, essentially the physics equations that would guide it home. It executed a built-in test, checking 147 different parameters in under a second. All systems green. This missile was healthy and eager to fly. Range verification, 5.5 kilometers, optimal. The Hellfire can reach 8 kilometers, but at 5.5 it arrives with maximum kinetic energy and precision. Laser track, rock solid. Despite the boat's best mechanical bull impression, all parameters showed green on the weapons display. The pilot stabilized the aircraft at 2,000 feet, minimizing vibration for the critical moment. Then came the authorization through his headset. Viper 2-1, your weapons are free. Cleared hot. In military terminology, that's permission to express deliver some American diplomacy. At 10:09 hours, the pilot squeezed the weapons release and the Hellfire departed the rail. The solid rocket motor generated 500 pounds of thrust, accelerating the 108-pound missile from 0 to Mach 1.3 in 2.5 seconds. That's 20 Gs of acceleration, enough to liquefy a watermelon. But the missile's electronics were engineered for this punishment. The missile's autopilot immediately assumed control, the guidance system essentially calculating, okay, I detect laser energy bearing 186, depression angle 12 degrees, currently at 2,000 feet, speed Mach 1.1, distance to target 5,100 meters. Need to climb for energy accumulation, then dive for optimal impact angle. Every 20 milliseconds, 50 times per second, it updated its solution, using proportional navigation to calculate the perfect intercept point. It's the same mathematics a quarterback uses to hit a receiver in stride, except the receiver is constructed of fiberglass and about to experience the worst day imaginable. As the Hellfire accelerated, it encountered transonic buffeting, violent shaking as it punched through the sound barrier. The autopilot compensated instantly, fin actuators working frantically to maintain stability. The rocket motor consumed composite propellant at 12 pounds per second, each pound generating 5,000 degrees Fahrenheit inside the combustion chamber. The missile's exterior temperature climbed to 900 degrees from air friction alone. The missile climbed in an elegant arc to 2,500 feet, trading velocity for altitude like a roller coaster ascending before the major drop. The forward canard fins made microscopic adjustments, a degree here, half a degree there, each movement calculated to maintain the perfect trajectory. Then it pitched over into a 35-degree dive, gravity joining the equation, accelerating it back through Mach 1. Inside the warhead, the FMU-139 intelligent fuse was armed and monitoring. This isn't some basic impact switch, it's an intelligent device that knows precisely when to detonate based on multiple sensors. Set for instantaneous contact, it would trigger the microsecond the crush switch detected impact. No delay, no penetration distance, just immediate conversion of explosives into mayhem. The Seekerhead never lost sight of that laser sparkle. As the missile descended, the sparkle grew from a light point to a distinct shape. The guidance system could now resolve the actual boat outline. 5 seconds to impact, the proportional navigation algorithm was solving its equations like an overachiever who reminds teachers about forgotten assignments. 3 seconds, the control fins locked into final approach position. 1 second, the Seeker captured its final image, a white fiberglass hull growing very large very quickly. The missile was traveling at 995 miles per hour, carrying 108 pounds of kinetic energy and malicious intent. The crush switch detected impact and the FMU-139 fuse transmitted the detonation signal in exactly 1,000th of a second. The 20-pound multi-purpose warhead detonated with the force equivalent to 28 pounds of TNT. The blast overpressure at impact point exceeded 200 psi, enough to transform steel into confetti. The fiberglass hull offered approximately the same resistance as tissue paper in a tornado. The TSS recorded everything in spectacular thermal detail. The initial impact created a white-hot bloom that saturated the infrared sensors for a full second. Then, the debris pattern became visible, a perfect 100-meter circle of what formerly identified as a boat, now reclassified as artificial reef material. Larger fragments, an engine cowling here, half a seat there, splashed down first. The smaller pieces descended like very expensive precipitation for the next 30 seconds. Viper 2-1, good effect on target, vessel destroyed, the pilot reported with the calm, professional tone of someone who just converted $1 million smuggling operation into a cautionary tale. The helicopter orbited once to confirm nothing larger than a beach ball remained floating, then banked north toward Iwo Jima. The entire engagement from missile launch to complete vaporization, 8.3 seconds. Less time than ordering coffee at your local cafe. The administration's message to smugglers had been delivered at the speed of sound, and unlike most government programs, it arrived under budget and ahead of schedule.